Good day to each and everyone. We are Group 8 and today we are going to answer and discuss the assigned tasks and questions for us. So what are we waiting for? Let's go to our topic. Number 1. Let f of x and g of x be polynomial functions. Determine if the function f of x squared minus g of x squared is continuous at any point c and explain why. Every constant function is continuous at every point, as is the identity function. Since the sum or product of continuous function is continuous, that means every polynomial is also continuous. So, basically, kapag ang given natin is polynomial function, given na rin na continuous siya. So, let's try an example. F of x equals 3x squared plus 3x plus 1 squared and g of x equals x squared minus 2x. So, isa-substitute natin siya sa given sa word problem. So, magiging 3x squared plus 3x plus 1 squared minus x squared minus 2x squared. So, makikita natin dito na kapag rinap natin yung example natin, matitrace natin siya na without lifting our finger and we can trace it continuously. So, therefore, the given example or this is an example of a continuous function.
Given questions to ask. Suppose g of x is a polynomial function and h of x is a rational function that are both continuous at x equals c. Determine if f of x equals g of x times h of x plus g of x is continuous at x equals to c, and explain why. And here are the three conditions. Number 1 condition. Define f of c approaches function exists at c. Condition 2. Lim of f of x as x approaches c. Condition 3. Lim of f of x equals f of c as x approaches c. And now, here are the solution or the sample of our question. Let's consider continuous function g of x equals x and h of x equals to 2x. First, note that g of x equals x and h of x equals 2x are both continuous functions, since they are polynomials and all polynomials are continuous everywhere. And next, number 2. Function f of x equals g of x, h of x plus g of x becomes f of x equals x, 2x plus x equals 2x exponent of 2 plus x. Next, consider the function f of x equals g of x, h of x plus g of x, which can be written as f of x equals x times 2x plus x. Simplifying this gives f of x equals 2x squared plus x. And next, since g of x and h of x are continuous, f of x equals 2x exponent of 2 plus x is continuous at any x equals c. Now, since both g of x, h of x equals 2x squared and g of x equals x are continuous function, their sum f of x equals 2x squared plus x is also continuous at any x equals c. This follows the property of that the sum of continuous function is continuous, and since c can be any real number, f of x is continuous for all values of x. And now, here are the conclusion. The limit of an exponential function exists for any real number c. This is because of the fact that exponential functions such as f of x equals e rapidly increase or decrease when a approaches closer to positive or negative infinity, respectively. Thus, as x approaches any real number c, the value of the exponential function approaches a finite limit.
Now let's move on to question number 3. Consider the function f of x is equals to the square root of x. Is f of x continuous at any point c? Explain why. The function f of x is equals to the square root of x is continuous at any point c if c is greater than or equal to 0. To further explain this, let us first consider the three conditions of a continuity. So first, define f of c. The function should exist at c. Number 2, the limit of f of x as x approaches to c, it should exist. And number 3, the limit of f of x as x approaches to c should be equal to f of c. Now we have here the solutions for the three conditions of a continuity, and as we can see, they are all equal, so the three conditions have been met. However, since this is a square root, the answer as stated before is that c should be greater than or equal to 0. This is because the square root of a negative number is undefined or is not a real number. Therefore, to ensure that the square root of c is defined, c must be greater than or equal to 0. This restriction or concept is specific to the given function f of x is equals to the square root of x. So now we have an example. So let us say that f of x is equals to the square root of x and c is equals to 9. So for us to define f of c, let us substitute the value of c. So f of 9 is equals to the square root of 9 that will equal to 3. So for number 2, the limit of f of x is equals to the square root of x as x approaches to 9, that will also equal to 3. And so the answer in number 3 is the limit of f of x is equals to the square root of x as x approaches t is equals to f of c. And since they're all equal, we can say that it is continuous and c is greater than 0. And as we can see here, if the value of c is less than 0, for example, if it is the square root of negative 1, the answer will be undefined. This is because any number squared will produce a positive number. If you multiply a negative number to itself, it will become positive. So there is no true square root of a negative number. Therefore, if it is less than 0, if it's square root of negative 1, negative 2, and negative 3, and so on, the answer will be undefined. That's why we can see here in the graph of the given function f of x is equals to the square root of x. The graph starts at the origin 0, 0 and spreads out gradually to the right, strictly increasing for all x in its domain. So the graph approaches the x-axis but never touches or crosses it. So it is a smooth increasing curve that starts from the origin, spreads out to the right, and never dips below the x-axis. And so going back to the question number 3, the function f of x is continuous at any point c if c is greater than or equal to 0.
How can we determine that the right points where g of x is equal to tan of x is not continuous? First is we need to see our graph. As we can see, there's space between each vertical asymptotes. This is the vertical asymptotes where they have space between each other, and that's our right points too. However, these vertical asymptotes cause our graph discontinuity. These vertical asymptotes at x equals to 2n plus 1 pi slash 2, where n is any integer. At these points, cos of x is equal to 0, making tan of x undefined. As x gets close to these points, tan of x heads towards positivity or negative infinity. causing the discontinuity.
Create a piecewise function where f of x is continuous at any point x is equals to pi. So now, we have the piecewise function f of x is equals to 3 plus sine x if 0 is less than or equal to x and x is less than to pi, and 3 plus x minus pi raised to 8 if x is greater than or equal to pi. Let us solve 3 plus sine x. 3 plus sine pi is equals to 3 plus 0 and it is equals to 3. Now let's move on to the second condition. 3 plus x minus pi raised to 8. 3 plus pi minus pi raised to 8 is equals to 3 plus 0 and it is equals to 3. So we have three conditions to satisfy to determine if the function is continuous at any point. The first condition is f of c is defined. So we have f of pi is equals to 3 plus x minus pi raised to 8, and that will be 3 plus pi minus pi raised to 8 is equals to 3 plus 0, and 3 plus 0 is equals to 3. Now we can say that the f of c is defined because the answer doesn't equates to 0. Now let's move on to the second condition. Limit of f of x exists as x approaches to c. Now we have limit of f of x is equals to 3 plus sine x as x approaches negative pi. So now we will get the answer 3 plus 0 is equals to 3. For the second one, we have limit of f of x is equals to 3 plus x minus pi raised to 8 as x approaches positive pi. That will lead us to the same answer, 3 plus 0 is equals to 3. So now let's move on to the last condition. Limit of f of x as x approaches c is equals to f of c. Since our f of x as x approaches phi is equals to f of c, we can say or we can determine that our function is continuous at any point of x is equals to pi.